Okay. So I'm broadcasting. Yeah. So I don't know. Yeah, just not going to a meeting, and putting false on the quiz and stuff of participating. Oh my goodness, that knocks your grade down quite a bit.
Oh, I know. I hate that.
I know.
Well, and then that last quiz, there were um there were a couple. I mean, now we figured it out, but there were a couple that Phil and I missed just because we were misunderstanding
Mhm.
how to work the formulas.
Yeah,
Um,
I somehow got 100% on both the homework and that one. I don't know
awesome.
how, but then I because I wasn't at the meeting, it knocked me down to an 89 just not being there. That one that
Uh,
one true false question. So I was like, dang, but what was I supposed to do?
right, right.
I could have
Good.
got on with you guys from the bed, like, retching the whole time. That would have been
Right.
fun for you all. So,
Oh, okay.
okay.
Um, maybe after this, I'll have to ask you because there were a couple questions that I went to the
Okay.
meeting and I asked the Brother Bennett.
Yeah.
He helped me understand, but now that I'm looking at it again,
Mhm.
ones that we missed, I'm thinking, um, wait, why did we miss that again?
Okay, well, let me go to that before I open up the
Okay,
new group quiz and stuff, and then I'll see if I can help you. Because there were a few that I almost did backwards, and then I
maybe that's what
looked
we.
at my notes and did it right. And so, let's see, group meeting. Okay, so which ones did you?
Number 7,
Okay.
if P is equal to a quarter, what is the smallest P?
Oh, I just got a text from Phil. Let's see. He
Okay,
says, "Hey, sorry, I'll be there in the meeting in a sec. Had to take care of my kids for a sec."
okay, good.
No
Then
problem.
we'll once he gets here, we'll be able to start. Well,
Yeah.
the n that satisfies the requirement, we put 10, but I guess the answer was supposed to be 40.
Yeah, because you have to do both that, what is it? The N times P, and you have to do the N, or yeah, N times P, and then you have to do the P, N, or is it P, or no, it's N times, and then you have the parentheses 1
Okay.
minus P.
1 minus
So
P.
it has to be both directions, and
Oh,
so,
that's right. And you
yeah.
literally worked it out to find out which one was the.
Yeah, exactly. I just went ahead and set up like a little Excel document, and I still have it up. But I just kind of set up an Excel document and then just kept plugging in the um, the different things until it kind of came up to be the lowest number for each. And the lowest number for the one was 10, and then the lowest other one was 30. And so it has to be equal to or higher than 10 on both of them. So if one is 10 and the other one's 30, then you go with the 30 as the lowest.
Oh, yeah, I got it.
Yeah.
That's what threw us because we just went to, well, it has to be the lowest it can be would be 10 because the requirement is that it has to be greater than
Hmm.
30. So that's why we didn't actually work it out. We just said,
Yeah. 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 You have to kind of work it out and stuff because it says if P equals 1/4, which is 0.80. I think that's right. It says what is the smallest n that satisfies the requirement. And so I had to kind of keep going in and plugging in numbers like 50 times
so
0.80.
what he was saying too for 1/4. So
Mm-hmm.
I don't know if this will help you in the future, but you use those two formulas, but for the P, you would, um, since it's a quarter, you would put
Oh,
25. So
uh-huh.
n times 0.25 is less than or greater, than 10, and um, that is equal to, if when you work that out, the equation out, solving for n,
Mm-hmm.
40, and then on the other one, the n times 1 minus p, putting in the 0.25 for p, solving for n. The answer is 13 point something, which doesn't satisfy the he was saying it doesn't satisfy the requirement. Why would he say that? Because that's still greater than 10.
Which one?
Well, I guess either way, what is the smallest?
So wait, 1 divided by 4 is that 0.25? Let's see.
So it'd be 1 minus 0.25.
Yeah, 0.25, I just took the 0.25 and I just took different numbers and plugged them in and multiplied it by 0.25. And then I took the other equation and plugged in numbers, you know, for n, that, and then found the one that matched the closest for the 0.25. So like for this one, let's see. We'll get my Excel book up. So like 0.25 times 40 and stuff, you know, it's it comes out to 10 exactly. So you know it's not going to be smaller than 40. And then for the other one, I did 40. Let's see. Is this right? Let me see. Yeah. So this other one I got like 30. Why do I have 30 on here?
So if you were to
oh, I see. That's the lowest required, and it comes out to 30. Okay, so like 40 times parentheses 1 minus 0.25 comes out to 30. So it's like the lowest required number would have to be for n. It would have to be 40. But anyways, I'm sorry. What were you gonna say?
Oh, I see what you were doing. Oh, okay. I understand what you're doing. Yeah, you just worked the problem backwards.
Yeah, just putting in, just plugging in different numbers.
Okay, that makes sense. And then the next one, we missed number 8. What is the mean of p hat? And I don't know if we just, I think we just plugged in the wrong formula on that one, because it should just be x over n, right? But somehow
yeah, the mean of p hat is going to be the p, if they don't give any other information. So it was just write what was right in there. Says use the following informations to answer questions 8 and 9. Suppose n equals 24 and p equals 0.4. So p, where was it? It was on I think the individual homework assignment.
Yeah, I remember that. So I guess what I don't. Why did we try to figure that out then? Or how did we even try to figure that out when I have no idea how we got 0.07? Because I know, I remember that, where the P would be the P hat. So I don't even know how we would have figured out 0.07 because we don't have X. Okay, so I'm not sure what we did with that one, but the answer makes sense.
Yeah, I mean, some of them you do, like, you know, where you divide.
Yeah, like 10.
Yeah.
We got 10 wrong, too. But for 10, so the 10 would be you'd use the equation x over n, and you would it'd be 35.
Yes, because
100.
Yeah, because you're dividing. You're dividing. What is it? The
number of hits.
30. Yeah, 35. You're going to divide that by 100, and so it comes out. I know. I almost got that one wrong. I almost put 0.3. And then I'm like, nope, this one's a little different because you got more information.
Yeah.
So.
Okay, that makes sense. And then the z-score, we got 12 wrong.
Okay.
Z-score round.
I got 1.091. And that one I almost got wrong too because I almost did it backwards.
So would the formula for that just be, let's see, z equals p hat minus p divided by the square root of p. Okay. So I think we must have just plugged in a number wrong or something because we understood the formula, but we just somehow got it wrong. And then what's the probability? The one right under that. What's the probability Brittany gets at least 35 hits in her next 100 bats? Isn't that the same?
It's 0.138.
So how did you figure that out?
That's by using the normal probability app. So you plug in the z-score, and then you're looking for at least. Well, they say at least in 13, but if you look at the original question, it's more than 35, and so you're thinking at least or more. So I did greater than that 1.091. And you would, if you didn't get the z-score right, you're not going to get the p-score right. Yeah. Which is the probability.
Yeah. And then we almost got the 15.
You might be able to get partial credit. You might be able to get partial credit on 13 if you talk to Brother Bennett. Yeah, just because if you're consistently wrong in the same direction, you got 13 wrong because 12 was wrong, then he might be able to give you credit.
Okay.
So I don't know. I can't promise that, but I've talked him into giving me partial credit on a few. So. Okay, and then you got 15 wrong too?
No, we got the rest of them wrong. That was 15. The other on 15 we were so 14, 15, 16, 17, they're all connected. And on 14, it took us a while to figure out 14 because we weren't quite sure if we should use the 50% or the 0.50 or the 0.52. And anyway, we figured it out, but
yes.
It took
that's a hard one. I had circled that. I was doing it the wrong way at first, and then I had circled that problem, and I went to the key because the key had a different answer than mine.
Right.
And then I realized, no, you're taking the 0.50 minus the 0.528, and then dividing it by the square root of 0.528 times 1 minus 0.528 divided by, or not 528, 52. I'm sorry, I'm looking at number 9, but it's very similar to number 9 on the individual homework, or on the homework assignment. Yeah, not the individual prep, but the homework.
Yeah, we got that too. That's how we corrected it actually, because we were.
Oh, good. Yeah.
That same thing. We're like, wait a minute. I would have missed those too.
Yeah. So it's hard because you have to be careful, not to do it in the wrong order, and I could still get caught up on that, but I just keep looking at my notes really carefully, trying to figure out, okay, which way was it? So. Yeah.
I'm with Bill though. I wish our exams could be group. I wish we could take them with our group, because then we can check each other.
Yeah, no kidding. Yeah. Although sometimes, hey, glad that you could join us. I guess sometimes though they do we lead each other astray too. So I don't know, but most of the time I think we help. So I think it's good.
Where are you guys at?
We were talking about the last quiz, so just going over it. So you didn't miss anything.
Okay, good.
Okay, let's go ahead and get into our group meeting. Okay.
Okay, is everybody open?
Yeah.
Ma'am.
Okay, so number 3, the symbol for the population is hat, P tilde, or P. And it's
I think it's P, but let me see.
that P tilde. I sent in a question. I posted a question anyway for Brother Pennant because there was nothing in the reading material that covered P tilde. That's the P with the squiggly line over the top of it.
Yeah.
But the preparation assignment answer key, they answered all of their problems with P tilde instead of cat. I don't know if you noticed that or if you watched them, but and then a bunch of then all of the additional links that are for the homework or for the reading in the textbook. The guy was talking about P tilde too, so I have no idea what that P tilde is or why you would use that one over P hat or I'm not. There's nothing covered in it, but we know for sure that the true population is P because P hat is the sample.
Yeah, it's P.
Yeah.
Yeah. I'm not really sure what the differences would be either for the tilde.
I don't either.
I watched all the videos and took.
I did too. So I know what the formulas are that they use to find P tilde and stuff, but I don't know
when you would use it.
There's no other information.
Yeah, that's a good question.
Okay, so number 4, the requirements for constructing a confidence interval satisfied in the above information. Oh, so we have to figure that out again. That goes back to what we were just talking about.
Yeah. So we have to do both. So n equal. I have my Excel sheet still up. So n equals 100 and p equals 0.25, and p hat equal. Well, I don't think we need p hat.
So we just have to do NP is greater than or equal to 10, and then work out the n times 1 minus.
Yeah, let me make sure that. Yeah, it's the same conditions. It's in, but hey, wait, it's okay. And number 3 for this is less than 17. And number 3 for the preparation assignment, it says conditions to build one proportion confidence interval. Is that what it's asking?
It's just asking if they're satisfied, and we won't know if they're satisfied.
It says n times p hat is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10. So we do need both of those numbers. So it is a little bit different. Because I think before it was just P and not P hat.
Right, they didn't give us an N.
Yeah, so we need P hat as well. P hat equals 0.10. So we need to figure out what number, if N is enough. So let's see. So
if you do N times 1 minus P hat, it is, because it comes out to 90.
What? So wait, what are you doing? So I just multiplied to figure out if they're satisfied. You just have to figure out if NP, because there are 2 requirements. If they have to NP has to be greater than or equal to 10, and also N times 1 minus P has to be greater than or equal to 10. So when you just plug in the numbers, 100 times 0.25 is greater than or equal to 10. Work that out. If it is greater than or equal to 10, then that one checks. But then we have to also plug in the numbers for the n times 1 minus p. And if that ends up being greater than, then that would check. So both requirements would be satisfied.
They are.
And I get that they are too. I got 25.
Yeah. I think that mine is going to be 2. So let me just. Yeah, I got like 10 and 75. Let's see. No, this is not the right number.
25 and
90.
100 times p hat, which is 0.10.
P hat. It's just you just have to do p. because the p hat doesn't matter for right now.
Actually, for this lesson, it does.
Yeah, I thought you had to do n times p hat.
Yeah, n times p hat on this one, 100 times 0.10 is 10, and then the other one,
Should be
100 times the parentheses of 1 minus, and then it's this time only p is 0.25, comes out to 275. But they both require it. I mean, they both satisfy.
So wait a minute. So like in the preparation assignment, this is almost identical to the 6th question, right?
This is a different, this lesson, it adds on. So now there's like a p hat. It's n times p hat is greater than or equal to 10.
But do you have your, so the 6th question on the preparation assignment asks if the conditions are satisfied so the sample size is large enough that the central limit theorem suggests that the sample proportion p hat is approximately normal. And they're just giving us, all we have is n, p, and p hat.
Oh, okay.
You figure out if it's normal, you would still use the equation np is greater than 10 or n times 1 minus p is greater than 10, even if it's a p hat.
I think I was looking at number 3, though, which is conditions to build one proportion confidence interval above. 3 on the preparation assignment.
Right. But that's still NP. Oh, that is, yeah, that's the NP hat. Well, does it change it if you use P hat?
No.
I mean, it's also, yeah. I just wonder okay, because one is asking for the confidence interval and the other one's asking what conditions need to be satisfied to sample size is large enough that the central limit suggests the sample proportion P is approximately normal. So I really don't understand what the difference is. I guess there's 2 different requirements.
The confidence interval. Does it say? I thought I wrote that somewhere in my notes.
Yeah, it looks like there's like 2 different requirements and stuff. So
100.
Oh, here it is. I got it.
Okay.
It says in the summary on the learning, the lesson, whatever, it says the requirements for a confidence interval are n p hat is greater than 10 and n times 1 minus p hat is greater than 10. The requirements for hypothesis tests involving one proportion are np is greater than 10 and n times 1 minus p is greater than 10. So
where are you reading that?
This is in the lesson 17, inference for one proportion, and it's in 5. It's in the summary, the 5 summary. It's very bottom. It's the remember thing. But for confidence intervals, you use p hat, and for hypothesis testing for one proportion, you just use p.
Okay.
Okay, I'm going to write that down. Hold on just a minute. So hypothesis. So for the hypothesis test requirements, right? Is that what you're saying?
Yeah.
Requirements, we use just the P.
Yeah.
And then for a confidence interval?
We use p hat.
Okay.
Okay.
I knew I read that somewhere.
But the second equation is still the P, right? I mean, the confidence interval for the n parentheses 1 minus P stays the same, right?
No, it's p hat.
Is it P hat as well? Oh.
Yeah. Well, no. So for either one, to answer number 4, both of them satisfied. But what I was worried about was when to use the P and when to use the P hat. So the next question, question 5, they're asking if their requirements for conducting the hypothesis tests are satisfied. So then we would use just the P formulas. n p
Yeah.
is greater than or equal to 10, or n times 1 minus p is greater. But either way, for this problem, they both check out. So,
Yeah.
Okay.
but in the future, we might not be so lucky, you know.
Okay. Yeah. No, it's good.
Sure we're using the
It's
right.
good to know now. So does it check out if you plug in 0.10 then for both?
Yes, it does. Whether you're using p hat or p.
Okay, so that's 10 and 90, and then if you do the p, it's 0.25, so that's 25, and then 0.25. Okay, so I got 25 and 75, so yeah, I think they both satisfy it, so.
Is that what you're getting, Phil?
Yeah.
Yeah.
Okay. Okay, a study of the first-degree murder trials were conducted in another state. A random sample of 60 people on trial for 3-degree murder. Oh, that doesn't make sense. For first-degree murder was taken. Of these, 45 of the defendants were found guilty. Use the information to answer the question. Okay, find p hat, the point estimate for the proportion of first-degree murder defendants who are found guilty in the state. Well, wouldn't that be 45?
Well, it's 40. Isn't it x over n? So 45 over 60.
Oh yeah. Yes, you're right.
Yeah. So it's a 60 sample of 60 people and 45 out of the 60. So we divide 45 by 60, which gets 0.75.
Well, wait. I think you did it.
0.7.
Yeah, 0.75.
But it's 3 decimals, so add a 0.
Yeah.
I hate that.
I know.
It always makes me nervous. Okay, create a 95% confidence interval for the true proportion of first-degree murder trials in the state. There is a verdict.
You can plug this into that spreadsheet that they gave us, the copy of category data analysis.
Yeah, I did not know about that until I went to that.
So what is X, you guys, if you're looking at it, and I'll plug in the numbers and see what we get here.
X is 45.
Okay, and what's N?
60.
60.
And we keep it at, we should keep everything else. Oh, wait, do we want less than?
Well, that won't matter for the confidence interval.
And does it have a null hypothesis or nothing?
No.
Okay, it always puts 0.60 in there, and if you change that, it does change the number, so I'm always not sure.
Mine always opens with a 0.70. I wondered if that was going to be the
Maybe
null.
we should work it out by hand. I'm not very confident with the spreadsheet. It seems like you put in one thing wrong and it changes the numbers. So
the confidence interval, what do you, just to have something to just compare, what are you getting for your confidence interval without changing any other information, just putting in the X?
Oh, what am I getting on that Excel sheet? I get 0.626 and 0.843.
Oh, wow.
Okay, I'm getting a 40 and an 860.
That's what I got.
You got what?
I got 0.640 and 0.860, which is an error.
But ours, so check your null hypothesis, Phil. Are you, because mine's computing at a 0.70 null hypothesis. Is that what you're doing too?
0.7, yeah.
So yeah,
mine comes up as a 0.6.
When I pull up my program, it automatically has the 0.70, and I just opened it just now from the statistics page.
I did too.
Yeah, mine is from, I think I downloaded it at the beginning of the semester, like when they first gave us all the spreadsheets, so yours is probably more accurate.
But to double check, we could just...
We should do it by hand.
So what is...
the formula is, what is it?
Plus or minus 1, right?
P hat minus Z times square root of...
So now, would we use... Oh, yeah.
I gotta write this down so that I can work it out, because
It'd be 1.96 times.
P plus or minus Z, and then square root of the P tilde, right? This is where we use tilde, right?
No, not necessarily. We don't. The tilde, I don't want to use tilde unless it specifically asks for either the Wilson confidence or a +4 confidence.
I thought we were supposed to use the tilde for this whole lesson, like that's what the confidence interval is for lesson 17.
So where is that? This is what was confusing, because in the answer key for the preparation assignment, they don't use P tilde at all.
This was for the videos talking about the confidence. Talking about the confidence interval, and he gave for both the confidence intervals on the video, he gave P tilde plus or minus Z times P tilde 1 minus P tilde over N plus 4.
Right. Well, but that's what's confusing, because on the video they did it, but if you were to download the answer key for the preparation assignment, they did not. They just used P hat. So let's work them out and see if they're different.
Yeah, guys, I gotta go help my wife real quick.
Okay.
That's all right. Okay. So what is the P? Is that like the divided by?
What do you mean?
0.75, and then Z is this a 95% interval?
Yeah. So.
Or are we always just assume?
Right. So our P hat.
I mean,
750.
Is it 1.96 because we assume it's a 95% confidence interval? Okay. And 0.75, which I think would be P tilde anyways, because I don't know what other number we would use.
Do you want to work it out using P tilde, and I'll work it out using just P hat?
Well, what's the difference? Because
I don't know. Because in the reading, it doesn't.
We're only given the two numbers, so the only thing we could do is take the 45 divided by 60. So I think that would be the same number either way. So, yeah. So I'm just doing 0.75 plus or minus 1.96.
That's what I'm doing. So that'd be the P hat. And what was it? 60 people?
It's
Yay, I want to do that.
Yeah, it's out of 60.
Okay.
Is the number, and then plus 4. Okay.
Okay, so when we're doing this by hand, we work out everything that's. What is the order of operations that you do?
Well, I'm going to work it out in the Excel because it won't let you do it wrong.
Okay, I'm going to do that then.
Yeah, I'm going to do that. So, and
I missed
I'll copy and paste it and do the minus side as well. 1.96. Yeah, it's just about parentheses in Excel. It's just knowing where to put parentheses. So multiplying by the square root of 1 minus minus 75. Okay, divided by 60 plus 4. I'm going to put the parentheses in there. Okay, let's see if that works. Okay. I think I got the
Hold on. So,
okay.
working over here.
Anybody out? Anybody out?
That's what I got.
Okay, I'm trying to copy and paste it, but it's not really working too well. I'm just gonna highlight this, copy.
Talk to your dad. I'm in the middle of it.
All right, I'm just gonna have to type it all out again because it's not letting me do the minus side.
Jerry, for one time. Yeah, Ella.
Just a minute, buddy.
Ella can have. Ella
Okay.
have a.
Okay, so when you're putting it into your computer,
Uh-huh.
so 0.750 or 0.75. Where are your parentheses? Are you putting parentheses around the?
I did one. I did one on the 0.75 plus or minus the 1.96. I put a parenthesis on either side of those.
And then the parenthesis on the
And then
other
and then you have to make sure you put a multiplication symbol before you put square root.
Okay.
And then that automatically puts one parenthesis in for you. And then you put another parenthesis for 1 minus 0.75. And then close parenthesis. And then divided by and another parenthesis 60 plus 4.
60 plus 4. Oh, because you're doing that other one, right?
What is it 60? Isn't that the number?
Yeah.
Okay. That's the n, right? And then it's plus 4. Okay, so I think I have the range.
I got it.
Okay, what do you got, Phil?
When I did it by hand, I got 0.6404 and 0.8596. So when we round up, it'd be 860.
I got completely different numbers using Excel.
Even from you. But I did notice on our options, our original ones still are on there.
Yeah, I know. Are you guys using the 95 confidence interval for the Z?
Yeah.
Yeah.
Okay, so here's what I did. I'll walk you guys through it when I did it by hand. So I started in my parentheses. I did 1 minus 0.75.
Wait, why would?
Why did you do the 1?
Yeah, well, yeah, why did you start there?
I don't know. That's just what the equations were.
Yeah, you have to do the p minus the p hat or whatever minus the z, which is 0.75 minus or plus or minus 1.96 for the top.
Yeah, I did
or
that.
For the side, and then multiply by the square root.
Yeah.
Oh,
Yeah,
okay.
I just started inside the parentheses and worked my way out.
Oh, okay.
Okay.
Does that make sense?
Yeah.
Okay. So you have the square root of the 1 minus 0.75 divided by.
So I did the 1 minus the p hat in the parentheses. I got 0.25. Then you times that by the p hat, which is 0.1875. You divide that by 60, which is the n. You square root that, and then you times that number by the 1.96.
See, that's where I'm different with you. So, because you have to subtract your n or your p hat from your it's p hat minus your z4. So it'd be 0.75 minus 1.96.
Yeah, but you have to
plus.
times all the numbers to the right by the 1.96 first.
No.
No, it's those two numbers together.
So I got the same answer that you got for everything that's under on the right side of the equation. The only difference was before you multiply it by z, you have to do the p hat minus z, and then multiply that group by your answer for everything on the left right hand side.
So did you get a negative 0.076 and a positive 0.169, Gina?
No, I got a negative 0.067 and a positive 0.151 or 151.
Oh, that's not good if we're getting different ones too.
Well, but the reason we're different is because I just did the p hat versus you did the Wilson confidence. You did the p tilde.
No, I calculated on my not on the Excel sheet they gave us, but just on a regular Excel document.
But for your equation, did you do p tilde plus or minus z times?
I don't know what the difference is. All I did is the 0.75 minus 1.96 and then plus on the other side, and then multiplied it by the square root of 1 minus 0.75 divided by the parentheses 60 plus 4.
See, that's the difference. So you did that's the Wilson interval, because when you added the 4 to the bottom half of the denominator under your the root.
The plus 4 is not, so you just don't do the plus 4 at all?
Because we don't have any p tilde information. All we have is p hat.
Okay.
So
so I'm wondering why that was given to us in this lesson if we're not using it.
That's what I'm confused about too, because it's not in our reading. So I don't know. I don't understand it either.
Yeah, because I'm getting an answer and you guys aren't.
What?
I said I'm getting the same answer that the Excel spreadsheet gave us, but you guys aren't. So I don't know.
So I think we should go with, especially if Phil. Can you show us how you're doing it?
Yeah. Hang on. Let me write it out, and then I'll put it up to the screen.
Okay. Because it just has to do with your order of operations. We're all using the right formula, and I think and the answer we got from the Excel was the 0.640. It was the second option, or at least the second option in mine.
Well, I'm going to take out my plus and minus 4. I'm just confused of which formula we're supposed to be using. It says in number 2, it says formula for one proportion confidence interval. So is this a one proportion or?
Yes, this would be a one proportion.
Okay, so then it would be p hat, I guess. So.
Yeah.
Can you guys read that?
Yeah. Okay. Oh wait, where'd it go?
So
Okay.
I get a 0.175 and a negative 0.078.
Okay, well we know that's wrong somehow. And that's different than what I have too, because that's not one of the options for our answers. But let's see what Phil's doing. Okay, so you started with the 0.75 plus or minus 1.96 times
6.75.
1. Okay, so all of that's what I was using. So
Divided by 60.
Uh-huh.
Then I square root it.
You square rooted all of it first?
Well, no, I did all these equations in here.
Uh-huh.
And got a number, and then I square rooted it.
So what was the number you got in there? Was it 0.003125?
Yes.
Okay. And then you square rooted it, so you would have gotten a 0.055901699, some crazy long number like that.
Yeah, something like that. And then I times it by the 1.96, and then I plus and minused it from the 0.75, and I got the answers on the thing.
Okay, let me try that. Hold on. 0.0559. Yeah, okay, I'm getting the same thing now. So it's just my order of operations. I missed a couple on the exam. I missed one on the exam because I did my order of operations wrong. So, but if that's going...
I'm going to take out my first set of parentheses and see if that makes a difference.
Yeah.
Okay, so which numbers did you guys come up with for...
So
what was
I got
640 and then 0.860 once you...
Okay, hold on. I think I'm almost there. Hold on just a second. I have like 0.623 and 0.877, but that's still not right, huh?
Uh-uh.
I think I just have too many parentheses.
0.05.
Okay, let's see if that... Oh, it's still doing the same.
So, but the only other question I have, Phil, so when we're doing this, so I'm getting the same thing we got in Excel, which is the 640 and the 860. But why is it a negative 0.640? Did you get a negative on the first number?
No, I did not.
I just put it in.
Because I did everything to the right of your p hat, just minus 0.75 to that.
Right.
Like 0.75 minus all that number. So the number I got when I times everything out was 0.1096.
Oh, okay. I'm getting the... No, I still get a negative 0.640. Why am I getting a negative? So I put for the negative minus z part. Do you know what I mean? So I got the 0.0559016999 from everything that's on the right side of the equation, and then I multiplied that by 1.96.
Okay.
99016 times 1.96, and I got 0.11740733, and then I subtracted
Oh, that's not right.
So what am I? Because I'm getting a 640. It's just the It's just a negative.
I'm not sure. That doesn't make sense. It's 1, 2, 5, 2, 2.
Yeah.
Yeah, I don't know how you're getting that number because I'm.
Why?
Are you guys both doing this on Excel?
No.
I am. I'm still trying to figure this out because it's just usually about parentheses. Oh, that might be right. Okay, I think I might.
I just figured it out.
Yeah, I think I just figured out mine. Okay, I think I got the right numbers finally. Yeah, maybe not. I've got 0.623 and 0.877. I'm still not getting the right number.
So, what I would do, Melina, then is don't use the download that you already have on your computer.
I'm not using it.
Just use the one that you
I haven't been using that. I've been just doing it on an Excel, on just regular Excel, new open document, just trying to do the calculations, equals, equation. I've got equals 0.75 minus 1.96 times parentheses square root parenthesis 1 minus 0.75 close parenthesis divided by 60 and then 2 parentheses. But I'm not sure. I think it's something to do with the parentheses.
Yeah, it's got to be. So, Phil, when you were writing it out by hand for the negative side or for the lower end of the interval,
Yeah.
The P minus Z, blah, 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 blah. After you got your 0.0559, after you got the square root of everything that was on the right, what did you do?
I times it by the 1.96.
1.96, and then what did you do?
I subtracted. I did 0.75 minus that number.
Oh, that's why mine's negative, because I'm doing that number minus 0.75, not 0.75 minus. That's why, okay. That makes sense for me.
Okay, I'm just not coming up with it. Which answer did you get, Phil?
0.640 and 0.860.
Okay. I'm going to have to figure it out later. It's something to do with the parentheses that I'm putting in, but I'm just still too tired to figure it out.
How are you feeling, by the way?
Not 100%, but I'm better. I'm a lot better. It was a pretty bad stomach bug, so it's going to take me a few days, I think, to get over it.
Oh, it's not fun.
No, it was not.
Okay, so so did everybody get then 0.640 and then 0.860?
I never got it, but I'm just going to have to go back to it later and keep messing with my Excel sheet.
Okay.
So it comes out that way.
Yeah. And I'm confident since we were able to do it by hand and using the Excel program, it's the same number. Okay, 8. If you increase the sample size from 60 to 80, what do you expect to happen to the width of the confidence?
Here, you guys, only one problem. That Excel document that we downloaded,
Yeah.
my number did come out. My confidence interval did come out to the exact to 0.626 and 0.843. It is one of those answers. It is one of those answers. Like, I was just glancing over it real quick, the copy of the category data analysis.
Right.
And it did come out, if I changed the null hypothesis to 0.70, the confidence interval says 0.626 and 0.843.
Well, even if you change your null hypothesis to 70 or 60, it doesn't change the confidence interval.
Okay, well, I'm just saying that with the X and the N and the confidence level at 0.95,
right.
it has, I don't know if greater than would change it, but it does have one of those answers.
But so it should be on less than, right?
And that doesn't even change it. I just changed that, and it doesn't do anything to the confidence interval. But the confidence interval says 0.626 and 0.843. And that is one of those answers that is on the.
So how are you getting that? Because even when I put my null hypothesis at 0.60, it doesn't change my confidence interval. It's still 0.640 and 0.860. So how are you?
I have, for inputs, this is for one sample z-test for proportion.
Right.
Okay, X is 45.
Right.
N is 60.
Right.
Confidence level 0.95.
Yep.
Okay.
And then the null, that's exactly what I have. I'm wondering, something seriously must be wrong with your, something is up with your thing. Because even if I change that null hypothesis to like a completely different, I'm changing it to any number, depending on a bunch of different ones, and it never changes my confidence interval.
Well, that's weird, because I'm getting the exact same answer as one of the options, 0.626 and 0.843.
And your type of test is?
One sample z-test for proportion.
It doesn't even matter, yeah. Yeah, that's what I'm using. And I meant for like the not equal to, less than, or greater than. That doesn't matter though. I don't know.
No, it doesn't matter.
Yeah, it doesn't. I don't know how you're getting it, because mine never changes from 640 and 860.
And the null hypothesis doesn't change it either. It stays 0.626 and 0.843.
And you just opened that one up from the statistics website?
This is one that I got from lesson, I don't know, whenever they started downloading these documents.
Close that and open up the updated one from the statistics website. See if that is the difference. Because Phil, you're getting the same thing I'm getting, right?
Yeah.
0.610 and the 860. So it's got to be that program, the program that you've got.
Okay, where's the document at? Category, oh, there it is. I just said fatal error, so let me try it again. I'm just going to go into course resources. You guys can start talking about the other ones. I just want to double check it.
Okay, if you increase the sample size from 60 to 80, what do you expect to happen to the width? Well, as the sample size goes up, the interval width goes down. So.
Well, see, I did the math again, and so I got the width of the confidence interval for the one we just did was 0.22, and the one that we from switching to 80, because you have to get a whole new p hat and everything. It changes it to 0.2176. So if you round it up, it would still be 0.22, but it is smaller. So is that still a decrease?
Yeah, it should be that it decreases. As a whole, as the sample size goes up, the interval will always get smaller.
You've got more accurate information, right?
Right.
Yeah.
And that has to do with the central limit theorem. So 9, to conduct a hypothesis test for one proportion, 2 requirements must be met, and those are the P, that NP is greater than or equal to 10, or N minus, yeah. Suppose P is a quarter, what is the sample size? Oh, this is just like that other one that we had on the last one. What is the smallest N that can be met for both, that can meet both requirements? So
20.
you just have to calculate for P.
It's 20, I think. Because if the sample size is 20 and you times it by 0.5, that comes out to 10.
So
and
why would
you
do 0.5 over 10?
What?
Oh, sorry. I was thinking you were saying something else.
And if you do the other equation, 1 minus 0.5 is still 0.5. 0.5 times n is, if it's 20, it should still come out to 10. So.
Okay, sorry, so say that again.
Okay, so you have to do the two equations, right? NP is greater than 10, or n times n 1 minus p is greater than 10, right?
Right.
Okay, so if you times n by 0.5, to get 10, it has to be 20. And if you do 1 minus p, which is it's 0.5 in this equation, so that still comes out to 0.5, then n has to be 20 again. So I think that's what that means, right?
Okay. Yeah, the new document is different. It comes out with the 0.640. I don't know why that would be.
Yeah, I would just not use the one that you have downloaded on your computer anymore.
Okay.
Because it's giving you problems the whole time, it seems like.
Yeah. Well, it was just for that one thing. That's a new thing, though. But yeah, I don't know. That's weird. Okay. So this one's asking about the confidence interval.
So that one would decrease.
Or you already passed that?
Yeah.
Yeah, we're on 9.
Okay.
And then 9 is what we were talking about before Bill came in.
Okay. Decrease on 8, and then 9. To conduct a hypothesis test for one proportion, 2 requirements must be met. Suppose P equals 1 divided by 2. What is the smallest n that can be, and both requirements still be met? So
there's got to be a way to figure this out without having to just plug in a bunch of numbers.
Oh, I'll work it out on mine really quick because I've already got it set up. So, okay, let's see. It's 0.50.
I know Brother Bennett covered this on the last meeting, but it's not posted it yet. So I don't have access to it.
Okay, so I'm just going to change the number.
So can you show us what you're doing on your screen?
Who, me or
when
Phil?
you were doing it by hand, so you just substituted, like, you started at 10?
Are you talking to me?
Yeah. When you were just working it out by hand, how did you?
Yeah.
So you just
Yeah.
10?
I'm down to 30 and I'm still getting above 10. I'm getting 15, so I'm gonna try 20.
Right. So,
Yeah, 20 brings it to 10 exactly. 20 is the right number, I think. Yes, 20 is the right number for this.
So how did you figure 20?
I just plugged in. I went from like 100 to 50 and down till it came to both equations. It was 10 or above the answer.
So 20. Wait, sorry. So 20 times 0.5 is equal to 10. So so you were saying it's not going to be any lower than 20. Is that what you're saying?
No, because the answer can't be lower than 10.
Okay.
It has to be 10 or greater. And actually on this one, both equations come out the same. Mm-hmm. So whether it's the number times the p or the number times the 1 minus p in parentheses, it's going to come out to the same number, and both of them, the number has to be 20 to equal 10 or above, which they both equal 10.
Okay. So the one right under that's the same is just 1/10 instead of 1/2.
Oh, okay. So that's a 0.10. So I'm going to go back in. Okay.
So it'll be at least, 5 times that, right? So 50 times.
Well, for the one side, I just did 90 times the 0.1, and it came up to 9. So that's too small of a number.
Yeah, 20 is too small because I just changed it to the 0.10. So I'm gonna go. It's small by a lot. So I'm gonna go up to 50, just to jump it up.
I think it's 100.
Yeah, that's what I got. But it's gonna be 10 times.
Yeah, I think you guys might be right because 50 is way too small. Yeah, let's see. So I get 100 equals 10 for the parenthesis one, and then if you do it on the other one, it's 90, and both of those meet the requirements. So yeah, I think you guys are right.
Any smaller number, and you're not going to get it.
Yeah, exactly. So it's going to have to be 100.
So wait, you did 100. It's not 100 on both sides.
No. Well, no, it is.
The answer is it's the number is not going to change. It's going to be 100, but the answers of what it turns out to be will be different. But as long as those answers are above or equal to 10, then they meet the requirement. So on the 100 times 0.10, it equals 10. And 100 times 1 parentheses 1 minus 0.10 equals 90. And so both of those are greater than or equal to 10. And so, but the number that satisfies that both of those are greater than or equal to 10 is 100. Does that make sense?
Okay, that makes sense. I just didn't work out the n times 1 minus 0.10, so I was I thought I had heard you say something else, but
okay.
Okay, so it's 100. Sorry, this is taking forever, guys.
Yes, it is. I know. It's like a long day.
For questions 11 through 16, use the following information. For the water quality study in the reading, about 60% of the microinvertebrate water quality indicators have historically been associated with good health. The researchers suspect the water quality has decreased. They should conduct a hypothesis test using the significance level 0.05 with the following hypothesis. They collect new data, and this time samples, and 38 were indicating good health. The conditions for treatment are satisfied. So we just have to do the same thing but plug in the numbers. We don't have to guesstimate. We don't have to find n. So it's 80 times 38. Has to be greater than or equal to 10. And then 80 times 1 minus 38. Right?
I think you're right.
Well, to get P, don't we have to do 38 divided by 80?
Yeah. Yeah.
Oh, you're right. Sorry. So 38. Oh, I missed that last time. So it would be
38 divided by 80.
Yeah.
Yeah, 0.475.
Yeah, that's what I got.
And then you type that in, right?
Yeah.
And okay, so I got my answers whenever you guys are ready.
I'm
Okay,
almost
I got
there.
mine too. I got that they are both satisfied.
Yeah, me too. I got 38 and 42 as the answers.
That's
Yeah.
what I got.
Okay.
Okay.
Good.
What is p hat? Well, that was 0.7
475.
or yeah, 0.475, right?
Mm-hmm.
Okay, now we find the test statistics. Now we have to find z. So the formula is going to be z is equal to p hat minus p over the square root of p times 1 minus p.
Is
over,
it p hat or p first? I can't remember.
it's p hat.
Okay, so it's the 0.475 minus the 38
Minus, no, it'd be minus,
minus.
Is this one we can plug into the Excel spreadsheet?
Yes, I think we can. If it gives us the right answer.
they have this exact one in the homework assignment too. So let me just check what they used to be.
Okay. N80 x 38.
Okay, so they use, find the z-score, they use,
I think the null hypothesis on this is 60%. Is that right? Yeah, 0.60. Yes, it is.
that's what they use too.
And we're looking for less than, so let's use the document.
Yep.
Okay.
So it should be so our p should be 0.6, right?
Yes, and it's less than, and what's the confidence level? Is it 0.95 still?
Yeah, because it's a
Okay.
significance 0.05.
Okay, so I come up with a z-score of negative 2.282.
I got.
That's what you got, Phil?
Yep.
Okay. I haven't worked it out yet. I was looking on the homework
Okay.
to make sure that we had the p right. So I'll go with what you guys. So negative 2.282.
Uh-huh.
Okay, the p-value would be the 0.60, right?
No. I got 0.011.
I got
Oh, p-value.
0.011.
I was thinking p, the population.
Oh, okay.
Did you guys just plug that into the
Yeah.
the whatever?
Yeah,
Excel?
I did.
So
I'm going to just check the normal probability app. I think that's right, though.
So when you were doing this on your Excel, so you didn't do this by hand then, or Phil, you just used the Excel
We
sheet?
used the Excel
Yeah.
sheet. Yeah.
So let me do that really quick just to make sure I know how to do it. So then for X, you guys put
38
38,
and you put 80.
and then N was 80, 95%, and then we did less than, right?
Yeah.
I thought it was less
No.
than.
Don't forget your null hypothesis was 60.60.
Okay.
And
so
I
then-
get the same answer with the normal probability app.
Oh, good. So your p-value is 0.011.
Yeah,
Okay. Oh, that is so much faster than working doing it all by hand.
I know, seriously.
Okay, what is the decision for this test?
Well, it's less than the 0.05, right? So reject.
Yeah. Is that what you're getting, Phil?
Yep.
Okay, which of the following best summarize this is the conclusion? And that would be there's significant evidence.
Sufficient evidence to conclude that water quality in the area has decreased because we were looking for less than. Excuse me.
Yeah. There is, it's that first one then, right? There is significant evidence.
Yeah, because we're rejecting the null, and they were trying to find out if it was less than. So that was the alternative. So
yeah,
it's saying that there's sufficient evidence to say that it is less than, so decreased.
Okay. Okay, so are we good with everything, or was there anything that anybody wanted to double check? I think the only one we really got hung up was that
7. Yeah.
that first confidence interval, number 7.
Yeah. I'll go work on my numbers later so it comes out to that if it's right. So I'm just like not sure why my not the Excel document, just a regular Excel sheet for calculation.
Why you're not, yeah, because if you want to double check in the future, we want to be able to figure out how to work
Yeah,
it.
I think it's just a matter of the parenthesis placement, but it's just, I don't know why it was coming out to something different. So, but I want to get that fixed so I can just save that
Right.
to my Excel calculations, and then I can just use that every time.
Yeah.
So,
Okay,
okay.
so are we ready? Submit?
Yeah.
I submitted. We got 100.
Oh, good.
Yay.
I always wait until you do it, Phil.
I know.
I mean, I'm not going to change any of my answers, but it's just nerve-wracking for me.
Okay.
I can't. I hate waiting, so I always jump in and do it.
All
Yeah,
right.
well, the Excel document that we downloaded did come out with the right answer. So, I mean, we just need to trust that, I guess. But, yeah, I'll have to keep working to make sure that the calculations are correct, too. But,
And make sure you use that new Excel document.
yeah, I'll just make sure I
don't know
keep that
why
one.
your old one, even when you put in a different null,
Yeah.
you a different answer. I don't know. That was weird.
It is really weird. I don't know. It's just the one, when they first said these are the,
I
these
wonder.
are the documents, the Excel tools, you can download all of these. You'll need these for the course and stuff. I downloaded them all at the beginning of the semester, so anyways, but yeah. But they didn't they say to use the most frequent one or something, or most current?
That's why I don't download it. I just open it up.
So it's odd, because if you would have gone with that one, you could have got the totally different answer. So
Yeah, got it
that was
wrong.
on the sheet. I'm like, that's really tricky, guys, like that's not very
But what
nice
are
to
the
people.
odds? Yeah. What are the odds that it would that your wrong answer would actually be one of the options?
Exactly. So it's like they were almost counting on people to use the old document, and I'm like, that's not very nice.
That is it.
So. Okay, well, I think we're done for this week. But
What are we? Are we still on track with our group project?
Yeah, I sent
Oh.
it last week, a week and a half ago.
Okay.
And I haven't gotten anything back on it yet.
Okay.
So we haven't been approved yet. As soon as we're approved, then assuming everything's
go.
okay, then we can go get our 10.
Gina, what were you saying was the place to go to do like the random?
So if you, the random.
Yeah.
Let me just pull it up because I don't remember it. And then I'll.
I was just gonna go through and enter the stores in my area that would carry the M&Ms and put that in there. Yeah.
Hold on just a minute. Let me pull it up.
Now, is it okay to use the same store and just go like, a week or two apart or something? Or
no, we have to actually do different places. But if you go on to M&M.com, there's a store locator, and it will list a bunch of them. Like in our document, I said that we would be doing. Oh, this is the wrong one. Sorry. Within a 15-mile radius of the store locator, the stores that they recognize that sell M&Ms directly from their website, plus the other ones, because it doesn't include like Walmart or Loaf and Jugs or any of the convenience stores, gas stations, or anything. So we can add to that list the places that we know are right near us too.
Okay.
So as a fat kid, and I know that we were supposed to wait, I already went and got my M&Ms.
Don't tell us that.
Well, I did everything the right way. So as long as our thing gets approved, our numbers will still work. But it's actually pretty cool. I did a spreadsheet of all the colors and stuff. It's pretty cool.
So how did you do your random sample draw?
What I did is I had my wife write up a list of everything around here with like a couple gas stations, Walmart, stuff like that, and then I picked from a hat.
Literally drew from a hat. Yeah, and I put that in as our sample methods. I said that we would either be using that number generator, or we would be literally picking them from a hat. So it's still correct. Yeah, you're still right.
And I have my wife.
A number generator? Is that what it was, or?
So it's http:// www.random.org/integers.
Okay.
It's just that it's the link that they gave us. I think it was like in lesson, I don't know, 4 or something, 5 at the beginning of the semester.
Okay.
So you'll recognize it as soon as it comes up.
Perfect. No, that's great.
And then, Phil, can you, so that when you are, because I think you're the one that's describing the data, can you email us your Excel sheet or a blank, so that it'll be faster for you to.
You bet.
Our number.
I need an email from you guys.
Okay.
Oh, okay. Mine is, go ahead, Gina.
Mine's, I'm just going to give you my home one instead of the school because I don't look at my school one very often. But it's Dorny Clan, DORNY.
Okay.
CLAN @msn.com.
Okay.
Mine is Shane, SHANENBLEU @hotmail.com.
Okay. I will send that spreadsheet right over.
Okay, because I think the next portion that's due, is it next week? I think it's next week when you have to have that.
What does he need to have? Is it something we have to all do? Is it the?
It's to collect the data. So yeah, we'll have to. It's week 10. So
okay.
So
we're gonna have to get our M&Ms like this week.
Yeah. Well, he doesn't have to submit his document until Saturday of week 10, and we're in week 10 right now. So he has.
Okay. Okay. All right. Sounds good. All right, guys.
Yeah. All right. We'll see you guys. Next week.
Yeah. Sounds good. Oh, you too. Take care.
Bye.
Bye-bye.